space is full of mysteries, but some of the strangest objects lurking out there are zombie stars. Yes, stars that die, but refuse to stay dead. Instead, they come back in new forms, continuing to exist in a strange half-life. Today, we're diving into the story of these stellar undead, the zombie stars, with a special focus on white dwarfs. But there's more to the Undead Star Club than just them. Let's start with the most common zombie star, white dwarfs. Our sun, like most stars, will eventually become a white dwarf, a star that has died but not completely. But first, it will expand into a red giant, growing many times its current size. After shedding its outer layers in a beautiful planetary nebula, what remains is a tiny, incredibly dense core. This core is the white dwarf, the skeleton of the star, a husk glowing faintly with the remaining heat of its former self. A white dwarf is only about the size of Earth, but it's packed with the mass of the sun. This makes it one of the densest objects in the universe. Just 1 teaspoon of white dwarf material would weigh as much as a car. But white dwarfs are nothing compared to neutron stars, a remnant so dense that a single teaspoon of it would weigh more than 1 billion tons. How did we discover these zombie stars? The story begins in 1783, when William Herschel first observed what we now call white dwarfs. However, it wasn't until the 1930s, thanks to Subrahmanyan Chandrasekhar, that we fully understood their fate. He discovered that if a white dwarf reaches a critical mass, 1.4 times the mass of the Sun, now known as the Chandrasekhar limit, it can no longer support itself and triggers a type Ia supernova. How does this happen? Sometimes white dwarfs don't just sit quietly. If they're part of a binary system, they can act like cosmic thieves, pulling material from their companion star. As the white dwarf steals more and more, it gets heavier. Once it reaches the Chandrasekhar limit, things get unstable. At this point, a runaway nuclear reaction occurs, causing the entire star to explode in a massive supernova. This explosion is so bright that we can use it like a cosmic light bulb to measure distances in the universe. But white dwarfs are only one type of zombie star. Meet their more violent cousins, neutron stars. When a massive star runs out of fuel, it doesn't go quietly. Instead, it collapses under its own gravity and triggers a supernova explosion. What's left behind is a neutron star. The extreme density of neutron stars can vary depending on their mass, but they are among the densest objects in the universe. These neutron stars can be just 20 kilometers wide, but pack the mass of multiple suns into this tiny space. It's like taking all of humanity and squeezing them into the size of a sugar cube. They're extreme in every way, and if you're unlucky enough to get near one, you'd be stretched into a noodle by its insane gravity. Neutron stars often come with extra powers. Some of them spin incredibly fast and emit beams of radiation from their magnetic poles. These are known as pulsars, like cosmic lighthouses. Pulsars were first discovered by Jocelyn Bell Burnell in 1967, and they spin so rapidly, some hundreds of times per second, making them one of the most precise clocks in the universe. But we are going to talk about these stars and magnetars in a future video, so stay tuned. Now let's talk about the most terrifying zombie star of all, black holes. When a star much larger than our sun dies, it can collapse into a black hole. Black holes are so dense that their gravity warps space and time, creating a point where not even light can escape. The idea of black holes was first theorized by Carl Schwarzschild in 1916, based on Einstein's theory of general relativity. But it wasn't until the late 20th century that we had observational evidence of these cosmic monsters. Black holes come in various sizes, from stellar mass black holes formed from the collapse of massive stars to supermassive black holes which sit at the centers of galaxies. There are even intermediate mass black holes, but these are rare and still a subject of ongoing research. These stellar corpses may seem like the final stage of a star's life, but they keep consuming anything that gets too close, growing larger and more terrifying. Some theories even suggest that black holes might hold the key to time travel, warping space-time in ways we can barely imagine. So, what have we learned? The universe is full of zombie stars, white dwarfs, peaceful but always ready to explode if provoked. Neutron stars, insanely dense remnants that can pulse radiation across the galaxy. And finally, black holes, the ultimate zombies, endlessly devouring matter. But the story of zombie stars doesn't end here. There are future scenarios that are just as bizarre. White dwarfs might merge with one another, creating an even more powerful explosion. Neutron stars could collide, creating gravitational waves that ripple across the universe. And black holes? Well, they could merge, grow, or even consume entire star systems. Some scientists even speculate that these dead stars could be harnessed for alien energy sources or used as engines for advanced civilizations. After all, who wouldn't want to tap into the incredible power of a zombie star? Zombie stars raise some fascinating philosophical questions. Can something that's dead really be alive in a different form? Do these stars represent the idea of eternal existence, even in the cold, dark depths of space? And what does it mean for a star to refuse death? Zombie stars have even made their way into popular culture, from science fiction to movies and books. They remind us that the universe is full of second chances, but also that death, like everything else in space, isn't always what it seems. So, next time you look up at the night sky, remember that out there, somewhere in the darkness, the undead roam, quietly waiting.